You will have heard, if you've done any of the stuff from this week, maybe a bit of last week, that there are 3 different types of ionic solids that you'll be working with: AB, A2B, and AB2 solids. So AB is something like barium sulfate. So barium sulfate has got 1 barium and 1 sulfate, so 1A and 1B. A2B is something like, let's say there was an example in the quiz where we've got 2 of A and 1 of B, and then AB2, which is something like lead chloride, where we've got 1 of A and 2 of B. So when they're talking about AB, AB2, A2B, it's just talking about the ratio of ions that are present in your compound. The reason that this is important is that there is a different way to calculate Ks depending on which one of these that you have. So it's actually just that AB has a different way of calculating Ks than A2B and AB2. So these two have got the same method of calculating than AB does. So they're slightly different. So the way this works, so barium sulfate is going to dissolve into its constituent ions, which is barium 2+ and sulfate 2-, which means that our Ks expression is going to be just Ba2+, SO4 2-. So no exponents because I don't have any big numbers, and I don't include barium sulfate because it is a solid. So I only use my ions, and you can see here that we just have 2 things that are multiplied together. For my A2B, it's going to look something like this. So we're going to have, oh my god, I can't spell, rubidium sulfate, which will be a solid, which will dissolve into 2 rubidium ions and 1 sulfur ion, which means that our Ks is going to be B plus squared. Oh my gosh, hands are not working today. Multiplied by the concentration of S2-. So they are different. This one's got 1 of both. This one's got a squared in it. And then the same for this side, we've got lead chloride, which is a solid, dissolving to form its 2 ions, lead 2+, and 2 chlorine ions, which again means that we're going to have a squared in our Ks expression. It's just on the anion this time instead of on the cation. So what we have here, we have 2 different equations that we can use to calculate the concentration of Ks. The reason for this, I'll go through it a little bit more in a minute, but basically with a normal equation that's not an equilibrium equation, you can assume that if you had 1 mole of X plus 1 mole of Y, that you would make 1 mole of Z and 1 mole of W. Like you would have equal concentrations being made, or equal molars being made of your products. So if you started with 1 mole of both of your reactants, you would make 1 mole of both of your products. We can't assume that with equilibrium equations because we don't know how much of our starting material actually has reacted to form our products. Because when we've got a normal reaction where it's just a straightforward arrow, we assume all of our reactants react to make all of our products. So we can assume that every mole of this that we use has been used up to form our products. However, in an equilibrium reaction, only some of this might have been used. So it's only going to make some of your products. But what we can assume is that this ratio that we've got, so 2 rubidium ions to 1 sulfide ion, is true. So however much sulfide I make, I'm going to make twice as much rubidium. I don't know how much sulfide I've made, but I know that I've got twice as much rubidium because of my molar ratio here. So hopefully that makes a bit of sense. So no matter what this gives me, I can't really use that to work out this, but I can know that I've got twice as much of this as this. We have to start making a whole bunch of assumptions in aqueous chemistry, which makes things a little bit tricky. So there are 2 equations that we use for calculating Ks. The first one is that Ks is equal to S squared, where S is the solubility of the ions. we have a second one, which is Ks is equal to 4s cubed, where again S is equal to the concentration of the ions, or the solubility of the ions, which is given in concentration. Ks equals S squared is the one we use for this one, for our AB solids. So all AB solids, when you're given the concentration of the ions, you square that. Because if you look at your Ks expression, you've actually got the two ions multiplied by each other. So because we assume that we've got exactly the same amount of both of our products, as soon as we know the concentration of one of them, we assume the other one is the same, and therefore we just end up squaring that number. So Ks is equal to S squared, where S is the concentration of the ion. Ks equals 4s cubed is for these two. So if you've got an A2B or an AB2 solid, so somewhere in your Ks expression you've got a little 2 up there, both of those use exactly the same equation, and that is 4s cubed, which is because you end up with, let's do this one, if I just put that in here, we would have, if we take from our equation, 2s squared multiplied by s, or here s, and then here multiplied by 2s squared, which equals 4s cubed. So you don't have to remember that that is why it is. You actually get both of these equations on your formula sheet for your exam. So you don't even have to memorize these. You just have to remember which type of solid it goes with. So your s squared is just for your really basic ones where there's only one of both. And 4s cubed is for your ones where there's a 2 in there somewhere. You will not be given one that has 3s or 4s because you're not expected to be able to calculate those. So you'll only be given ones where there's 2 of one of the ions or one of both. So I'll go through a question, and that might help some people out a bit. So let's say that we have got the concentration. Okay, so our solid is copper hydroxide, so Cu bracket OH2, and I have been informed that the solubility of my compound is 2.29 times 10 to the power of negative 7 mole per litre. You will sometimes see in questions that they give the solubility of the full compound, so they give the solubility of this, but that is still just S. So whatever concentration they give you, that is S. So we're given our concentration of 2.29 times 10 to the negative 7 moles per litre. So is this solid an AB, an AB2, or an A2B solid? Here's AB2, so we've got 1 copper and 2 hydroxide, which means it's an AB2. So am I going to be using S squared or 4s cubed for this one? 4s cubed, fantastic, because we're a bit more complicated. So my first step for all of these questions, and usually in your exam they will ask this as a separate question, so they will first ask you to give the dissolution equation. So your first thing will be to say, okay, well, I know that this is going to be this. Then they will ask in another question for another point, which is kind of nice. You get extra points for the stuff that you would have to do as part of the question anyway. It will ask you to give Ks, so my Cu2 plus multiplied by OH minus squared. And then it will ask you to calculate it. So Ks is equal to 4s cubed. Because this is an AB2 solid, it's slightly more complicated than a basic one, which means that you would go 4 multiplied by 2.29 times 10 to the negative 7 cubed. It is really important that you cube this first and then multiply by 4, rather than multiplying your concentration by 4 and then cubing, because you get a different number. So you have to cube S first, then multiply it by 4. And just a reminder for your calculator, you can put this one in as 2.29, press the X button, and then negative 7. And then you don't have to put brackets in. You can just cube that whole number. So that should give you 4.80 times 10 to the negative 20, and Ks does not have a unit, so just this number to 3 significant figures. If I give you, so our solid is silver chromate, so it's silver chromate, and the solubility is equal to, that does not need to be in square brackets, 8.66 times 10 to the power of negative 5 moles per litre. So your first step should be write the dissolution equation. Second step, write Ks and use that to determine if it's going to be an s squared or a 4s cubed. And then plug concentration in for S to calculate Ks. So I'll give you 5 minutes, see if you can give that a go. So you've got your S up here, your type of solid here, and your steps. So step 1, write your dissolution equation, write your solid silver chromate dissolving into its 2 ions, Ks, and then use that to determine which of the 2 types of equation you're going to use, and then chuck your concentration in for S. And remember, if you are doing 4s cubed, cube your S first, then multiply by 4. So our dissolution equation, so we have our solid, solid turning into 2 Ag plus and 1 Cr042 minus. So then from there, our Ks expression is going to be that we have got Ag plus squared multiplied by Cr042 minus. So that means that this is what? Is this a 4s cubed or an s squared? 4s cubed, fantastic. And then plug in the number, so Ks is equal to 4s cubed, which is equal to 4 times 8.66 times 10 to the negative 5 cubed, which should be, if I've put that in my calculator right, which I may not have, 2.60 times 10 to the negative 12.